Today, we're diving into a topic that's both exciting and urgent: AI and its role in fighting climate change. AI is becoming an essential tool in tackling the environmental crisis, from optimizing energy to analyzing climate data. Before we dive in, we found that 60% of you aren't following us yet. Please do us a huge favor, hit that follow button, and collect our episodes on pods.media. Your support means a lot. Thanks, guys. So we've got a stack of information looking at how artificial intelligence, we're talking machine learning, big data, automation is increasingly crucial in understanding and, well, more importantly, acting on the challenges of our changing climate. Our mission today is to really dig into how AI is becoming this surprisingly potent ally in the fight against global warming. We want to examine its concrete applications and, the real world impact it's actually having.
Absolutely. And it's easy sometimes to think of AI as this very abstract thing, right?
Yeah.
But here, it's incredibly practical, a very applied use of advanced computing. We're essentially using algorithms that can learn from just vast amounts of data. They identify trends, make predictions at a speed and scale that's just impossible for humans alone. This capability, this way of processing complexity, is becoming indispensable as we try to get a handle on, well, the multifaceted nature of climate change.
Okay, so let's move past the theory. Let's get into the specifics. How is AI actually being, deployed out there in the real world? Where is it making a tangible difference right now?
Well, one of the biggest impact areas right now is optimizing how we use energy. Just think about the sheer volume of energy consumption data generated every single day. AI algorithms can sift through all this information from individual buildings all the way up to entire power grids, pinpointing inefficiencies, predicting future demand. It does this with remarkable accuracy, and that allows for these real-time adjustments, making sure we're not wasting energy.
Wow, so it's like having this super intelligent energy manager working 24/7. The sources we looked at highlighted a really compelling example with Google's DeepMind.
Precisely. Yeah, the DeepMind example is fascinating. What's really insightful there is how their AI found these non-obvious patterns in operational data. Things like airflow, cooling adjustments, stuff that even, experienced engineers hadn't quite optimized. And that led to that impressive 40% reduction in energy use in their data centers.
40%?
Yeah, it really underscores AI's power to find efficiencies we might completely miss otherwise.
That is a massive leap. Okay, so that's making current energy use smarter. But AI is also helping us understand the climate itself better, isn't it?
Absolutely. We are constantly gathering just huge amounts of climate data. You've got satellite imagery, weather readings, ocean data, the list goes on. The sheer volume is just overwhelming for human analysis alone. AI models, often using things like neural networks, can process these massive data sets. They find complex relationships, track crucial indicators like, say, deforestation rates, predict weather patterns with much more precision, and monitor ecosystem health in ways that just weren't possible before.
So instead of researchers drowning in data points, AI flags the key trends and potential issues much faster. That sounds critical for early warnings for extreme weather events.
Exactly. And that same capability extends directly into renewable energy too. Solar, wind power.
No.
Their generation is inherently variable, right? Depends on the weather. So AI algorithms analyze weather forecasts, historical performance data, and they predict energy output from these sources far more accurately. This lets grid operators manage things much more effectively, giving us a more stable, more reliable supply of clean energy.
And we saw a great example of this, didn't we, with EXL Energy?
Yes, that's right. EXL Energy partnered up with an AI firm specifically to optimize their wind farms. They use machine learning to look at weather patterns, individual turbine performance, all that data. And they can make these subtle but really significant adjustments to how the turbines operate. The result, increased energy production and, importantly, lower operational costs. It really shows how AI makes renewables not just greener, but more economically viable too.
Okay, so it's hitting energy consumption, climate data analysis, and boosting renewables. It feels like AI is tackling this from, multiple angles, but why is this so important right now? What are the key advantages AI offers in this, frankly, urgent situation?
Well, the urgency is undeniable, isn't it? The climate crisis demands rapid, effective solutions. AI gives us tools to make quicker, much more informed decisions. A key advantage, as we've touched on, is just raw efficiency, reducing waste, optimizing processes across all sorts of energy-intensive sectors.
Less waste means lower emissions. Simple as that. What other benefits are there?
Another crucial one is scalability. The sheer scale of the climate problem and the data involved, it requires solutions that can handle immense complexity. AI's ability to analyze and manage these vast data sets means we can implement solutions at a scale that just wouldn't be feasible otherwise.
Right.
Think about managing a whole country's power grid or tracking deforestation globally. AI is built for that kind of complexity.
Yeah, it's not just tweaking one wind turbine, it's orchestrating energy for an entire region. And our sources also mention AI's role in preventing environmental disasters.
Yes, that preventive potential is really significant. Using predictive AI models, analyzing historical data, current trends, we could potentially identify disasters before they happen. Things like wildfires based on weather and vegetation data, or maybe the likelihood of floods.
Ah,
This kind of early warning lets us take proactive steps, mitigate damage, protect communities.
that's incredibly promising. So, who are the key players then? Who's really driving this innovation where AI meets climate action? Who should we be watching?
It's definitely still an evolving field. But yeah, several key figures and organizations are making really notable contributions. Reid Hoffman, for example, he's been a very strong advocate, hasn't he? Really emphasizes AI's potential as a game changer for global warming. He urges more investment in the research.
Right.
He even suggested applying AI to things like designing more sustainable fashion, which just shows the breadth of its potential.
AI designing eco-friendly clothes. That's a fascinating side application. And we already mentioned Google DeepMind's work.
Absolutely. Their 40% energy cut in data centers is such a concrete example of AI driving operational sustainability right within the tech sector itself. And EXL Energy optimizing wind farms shows its practical use in the energy industry.
What about the big tech companies generally? Are they making serious moves here?
Yes, definitely. Companies like Microsoft, for instance, through their AI for Sustainability initiative, they're very active. They're focusing on using AI for smarter energy grids, predicting demand better, optimizing distribution, integrating renewables more smoothly. And they're also investing in using AI to boost carbon capture technologies, making them more efficient, more scalable.
Carbon capture is so critical. Are there specific companies using AI for that effectively?
Carbon Clean Solutions is one that comes up. They're specifically using AI to analyze data from all sorts of sources to improve their carbon capture processes. So AI helps optimize the chemical reactions, find the best spots for storage, and even monitor the storage sites long term to make sure they're secure.
Interesting. And then there's Tesla, obviously known for EVs, but they're in the broader energy game too, right?
Exactly. It's not just the cars. Tesla uses AI extensively to optimize battery storage and energy use across their whole ecosystem. Solar panels, the power walls for homes, even their bigger grid-scale batteries. Their AI aims to make energy solutions for homes, businesses, and the grid itself more efficient and integrated.
It's clear AI is being applied really broadly. But, for these solutions to have a genuinely global impact, what are the big hurdles? What obstacles do we need to clear?
There are several key challenges, yeah. One of the most fundamental is probably data quality. AI algorithms are only as good as the data they're trained on, right? So for climate action, we need comprehensive, accurate, up-to-date data sets covering all sorts of environmental factors. Incomplete data, inaccurate data that leads to flawed analysis and ultimately less effective solutions.
Garbage in, garbage out, basically.
Yeah.
Makes total sense. What's another big one?
Cost. That's definitely a major consideration. Developing and deploying these sophisticated AI systems takes significant financial investment. You need computing power, specialized expertise, the infrastructure. This can be a real barrier, especially for, say, smaller organizations or governments with tighter budgets. It could even widen the gap.
So it's not just a tech challenge, it's an economic one too. And you mentioned collaboration earlier.
Yes, absolutely vital. International collaboration. Climate change is a global crisis. It needs global solutions. End of story. To really make AI work for climate action, we need strong partnerships. Governments, corporations, research institutions, international bodies, everyone needs to work together. Sharing data, sharing best practices, sharing the technology itself, that's crucial to maximize the impact.
These are pretty significant challenges. Data, cost, collaboration. But the potential payoff seems huge. So looking ahead, if we can manage to integrate AI effectively, what does that future look like?
Well, the potential is tremendous. We could be looking at truly intelligent energy grids, operating almost autonomously, optimizing energy supply, consumption, all in real time, based on AI forecasts and adjustments.
Wow. Imagine an energy system that's just constantly learning, adapting to cut waste and maximize clean energy use.
Exactly that. And AI will be a critical enabler for hitting broader sustainability goals, too, especially getting to net zero emissions. By optimizing renewable integration, minimizing waste across industries, AI can seriously accelerate our progress towards a sustainable future.
So AI could be a key engine driving that transition to a net zero economy. What about dealing with the climate impacts we're already facing?
Yeah, AI has a big role in mitigation there too. We talked about carbon capture,
Yeah.
but it can also boost how we monitor environmental degradation, deforestation, pollution, you name it.
And it can even help design new, innovative, sustainable technologies to directly tackle the effects of climate change.
It really does feel like AI could touch almost every part of how we handle this global challenge.
Yeah.
It's clearly a powerful tool, but like our sources say, it's not a magic bullet, is it? That's such a critical distinction to make. AI is incredibly powerful, yes, but its effectiveness hinges on careful development, responsible implementation, and, as we discussed, getting over those hurdles: data, cost, collaboration. But when you look at the tangible results already happening, the energy savings at Google, the more productive wind farms with the EXL, the improvements in carbon capture, it's clear AI is making a meaningful difference right now. The key now is really scaling those successes globally. And that means strategically tackling those barriers we talked about.
So a promising future, potentially powered by AI-driven environmental solutions, but it needs fast and, crucially, collaborative action to get there. That's a powerful note to end on.
Indeed. And maybe it leaves us with this thought to consider.
Mm.
As we rely more and more on AI to help navigate these huge environmental challenges, how do we make sure we keep human oversight?
Yeah.
How do we understand what these complex systems are actually doing? How do we prevent unintended consequences when we start delegating more of these critical environmental decisions to algorithms?